Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and we were just talking about how technology can only go so far when it comes to reliability, because whether we want to admit it or not, there's usually a human being involved, and they're very hard to engineer right.
Well, we've got, I'm just thinking, when you first brought this topic up, and I understand, technology in the concept of like an aircraft or a large, complex rocket engine or something like that. Yeah, people can push the wrong button pretty easy. But technology also includes a pencil or a hammer. But even then, if you leave a hammer where it gets rusty, it'll just fail on you if you don't do the proper maintenance and take care of it. Or a pencil, if you use it as a pry bar for something, it's probably not going to go very far. No,
but sometimes people do use pencils for pry bars.
Yep.
Small scales, obviously, and they will buy pencils that tend to be better at being pry bars than others. So that's the market.
Yeah, but there's a whole pile of different things that go on here, and we run into it all the time when you're working on the development of a project. Is, well, who's going to use this and how and where? I mean, we got to know the environment and use conditions and all those other things. But sometimes you can't imagine all of those. And then on the top of it, I think part of the discussion we were having before we hit record was that some people just override all those systems and cause mayhem anyway.
Right. I mean, the first cell phones, the first mobile phones, as big bricks, they were designed, at least initially, with the rich and powerful in mind. They were very expensive, they're very heavy, and they was initially intended to be a boutique product. But the demographic which accepted them the earliest and the most were the tradespeople, the plumbers, the electricians, who all of a sudden could purchase what was an expensive phone, but as opposed to having to go back to their office between jobs, they could go from job to job to job to job. Mm-hmm. And so there's an example of the device being used in a way which is not as intended, but it's certainly not abuse.
No, it's not abuse, but it's also, in the toolbox or on the seat of a truck versus
right
in a limousine.
Yes. And the mobile phone companies who saw what the market was saying and designed phones accordingly are the ones that were still around. Those that refused to adopt, they quickly went out of business, and a lot of them did go out of business. It's those that started realizing that mobile phones and cell phones were going to be products for the masses and not just the elite. That's where they started to take off.
Yep. Well, that's a whole thread though of how products become more and more commonplace. I remember the first cell phones were treated with kid gloves, because if you dropped it on the table the wrong way, if it bounced off the couch onto the floor, it was going to break. It would be 1,000 pieces. I don't know how many times I had to duct tape my battery compartment back onto these things because it'd be an inexpensive small plastic clip that hold the battery case together, basically. And if you dropped it once or twice, that one almost always broke, at least for me. And
then you had the Nokia 3210.
Yeah, you know the one.
Yep. For those younger people out there, there's this phone, the Nokia 3210, which was virtually indestructible. It could go through the wash a couple of times before it decided to stop working. It was very robust.
Very robust.
And it was the world's best-selling phone as a result.
Yeah. You didn't give it to a teenage girl because then it would get broken, as I learned the hard way with my teenage daughter. So
that said, if there was any phone that could survive the abuse of a teenage girl, you'd suggest the 3210 would have been the phone that would have had the best shot.
Yeah. Unfortunately, I don't think it had a browser capability or texting or anything. Maybe it had texting. I don't remember.
It definitely had texting, but of course, then the market changed. So then came the desire to have smartphones, and Nokia wasn't able to as quickly adapt. And so, what was their strength? quickly became a weakness, because now they're starting to get more and more robust smartphones, in that they can be water resistant and not quite waterproof. But when smartphones first came out, you couldn't put your smartphone anywhere near water, but people were happy to pay that price because they had a smartphone, which you browse, download apps and everything else. So that's why Nokia didn't continue to maintain their space in the market.
Well, the same could be said of same thing goes with cars. As cars have gotten more and more technology into them, and more screens and smarts and electronics and all this other stuff that's in it, if you're a bad driver, you're still going to overcome all of the automatic braking systems and everything else that's in it. But we also get so used to, it was the Tesla one. The guy it's a very early autonomous driving capability. And some guy was going down the highway in Florida, and a white trailer truck pulled out, and the car didn't see it. And the guy wasn't paying attention to his car, and it killed him. And it was kind of is this ever going to work, and all those kind of things. But it was one of those where inattention to that technology overcame it. And it wasn't designed to be totally autonomous. You were supposed to still have your hands on the wheels, kind of thing.
Right. And I must say, I shudder whenever I see those ads, which essentially show a stressed out mum or a late dad driving a vehicle, and they're not paying attention to the road, and the vehicle essentially saves them from crashing into,
grandma or
wandering across the highway, or whatever it is.
Yeah.
It almost suggests that it's okay for your driving skills to be less than okay, sort of normalizing a lack of inattentiveness, even though from an engineering perspective, those characteristics are inherently good. But now it's sort of getting to the stage, I would suggest, where some of us might be influenced to be less diligent. I'm aware of a story, I'm not sure how true it is, regarding the how many people died on building sites, those big high-rise building sites. I don't think about the Empire State, where workers would build that building with very little safety equipment. They didn't have helmets. They'd walk around, and of course now we have lines and zip lines and safety lines and helmets and everything else. But there hasn't been an appreciable or as big a decrease in deaths and injuries as you would expect. And suggestion being that with all these additional safety features, people now do more risky behaviors. So when you
push it to the edge, you push it to the edge because you have a pretty good shot at being saved, and then sometimes it doesn't work.
And then there's scenarios like what happened in China recently with the East China airline crash, which from where a Boeing plane just impacted the ground. It literally flew straight into the ground. And the preliminary suggestions are that was a deliberate act. I think the terms they were using was that the aircraft did exactly what it was told to do, which is suggesting that someone was telling it to fly straight into the ground. It doesn't matter how reliable that aircraft is. In fact, that aircraft was entirely reliable until it hit the ground.
Yep.
If there is a human involved, all bets are off.
Well, it's one of the hardest parts of but it's some of the failures and some of the scenarios that where people get involved is deliberate. They're just going to use it as inappropriately or maliciously or all kinds of different reasons, but there's also scenarios where people just, like you said, is they trust the car to do what it's designed to do, even though that it is a complex system and it's not foolproof, but they're going to push it all the way to the edge.
Right.
It's one of the reasons I got out of rock climbing is I'm looking at my belt and it's got a single point failure, a loop where you attach to the rope. And At the point I was, my harness was, I don't know, 5 or 6 years old, and that was kind of the expected lifetime of them. And I was like, do I really want to get another light? If I'm concerned about my equipment and I'm afraid to do what I've been doing on this equipment for a while, either I got to get a new gear, or get out of it. And so I ended up slowing down a lot of what I was doing with the capability. But it was, at some point I had a much higher risk tolerance, but I also had a lot more faith in my equipment. And as that eroded, then I pulled out of it. And it's the same with the cars. My wife's car, it's a Subaru, has an automatic braking thing built into it. And
Right.
the only time I ever felt it go is I was pulling into my in-laws' house, and it was a little bit of a ramp up to their garage. And we got, I don't know, we were 4 feet from the garage, and the braking system stopped us. And I said, I need to go a little bit further in so I'm not blocking the sidewalk, you know? So I had to
Yep.
trick the car to go, all right, it's okay. Diane was talking to it. It's okay. It's okay. We can go a couple more feet. And we crept forward real slow, and it was okay. Like, but I'm not going to go test it on the freeway, because
No.
if it doesn't work, I'm screwed.
All right. Going back to the climbing equipment, back in my military days, all our carabiners and everything else that we got, our figure eights,
Mm-hmm.
because as you know, if you drop them, they're done. You have to, if you drop a metal carabiner or figure eight or anything similar on the ground, or many of them at least, they're made out of alloys that will sustain these tiny little micro cracks in the inside, and that means it won't fail today, but it's going to fail. And so you can't inspect them. I
Yeah,
suppose you could X-ray them, but the ability to do that is just not. There's no.
not
You
feasible.
just
You
can't.
you just get rid of that one, and don't put it anywhere where somebody can pick it up and use it. You know,
Right.
just get rid of it.
So we never had like a central pool of these devices. You got yours, and you had to own yours. So and that the only defense we had was equipment husbandry, where you knew you were handling your own device, your own equipment, and if you dropped it, then you'd be much more likely to report it.
Yeah. Yeah, it was the same. When I learned, I was in a sport parachute club in the Army, and I never did the. It sounded so boring being a paratrooper because you're tied to the airplane and you can't, unless you're one of the Halo type folks. But I wasn't going there. I was in the artillery, and 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 we got to pack our own chutes, or were expected to pack our own chutes. We learned how to fall and land, but the next step was learn how to pack your own chutes. And yeah, you paid attention to it, because as soon as it
Yep.
doesn't open, you probably screwed something up in the packing. That's not a good feeling.
No, it's and I hate static line jumping. I just have to say that.
Okay.
Not
So
many people know that is, but I hated it. It was awful.
Yeah, but some of our products and the technology. I think back to that initial thought though is that to some of us it's just magic that this stuff works, and we take it for granted, and rightfully so, and it makes life easier or faster or more efficient or whatever. We do all these cool things, but it goes to, I like your story of the safety in building production type stuff, and it the safety systems and guardrails and everything else. I don't know, how many times have you seen somebody on a raised platform and has a guardrail and they're leaning way over it to change a light bulb?
Yeah.
They don't fall right now, but if that guardrail wasn't there, they wouldn't be leaning out like that.
No.
So I get that concept, but in the design of products, it's one of the hardest things to do is design for how people are going to treat and use your product 5 or 10 years from now, when they're very familiar with it, when they've learned to trust it and everything else, and it's wearing or aging or cracking or whatever. I've rarely seen that included in the design process.
Well, and then when you look at the Air France crash over the Atlantic Ocean, where a technology change where you had joysticks next to the pilot and the co-pilot fundamentally changed how two human beings could input commands into an aircraft. But I suppose the traditional approach to cockpit design, which most people are familiar with, is where the pilot and the co-pilot share a yoke. Well, they have their own yoke, but they're physically connected, so that when you push your yoke forward, the other one goes forward as well. And so, if there was a discrepancy between
whoever's strongest,
yeah, exactly. But there'd be no doubt about what the plane was doing. Air France. On the other hand, those joysticks where the pilot and the co-pilot couldn't see what was going on, what the other one was doing. One was pushing down, the other one was pulling back. And they had no idea until it was too late.
Yep.
But that sort of design was fixing a problem that didn't exist. It was the next level of technology. It was a different way of inputting information into an aircraft. It was, it involved deviating from the status quo, but it introduced this additional way the thing could fail, which clearly the industry didn't fully understand at the time.
So are we saying that the people that use our products and systems and everything else is the weakest link?
I don't think so. I think we can say they can be, but the point is that I think we talk about the vital few all the time, and you have to work out what the weakest points of your system are. We usually do that in a mechanical or a physical context. But there comes a point where you can make your thing so reliable that any incremental improvement in the mechanical or physical device will have a negligible effect, because by this stage, all the issues are being caused by human error or human mistakes. And so there's no point trying to improve the reliability of your system at that point in time. The next step you need to take to improve reliability is actually all about the user interface or the human-machine interface, or somehow working out why those human errors, which are part of life, are causing problems.
Yeah.
That's the next step.
Well, that's one that I've seen in medical devices paid attention to much more closely, where they know that there's nurses and technicians and surgeons or whatever and using their equipment. And there's a certain level of training that goes with it and understanding. But I remember one product I was using, it had it was a tethered device that did some medical procedure on people, but it was only, I think, 3 or 4 feet long. And the very first time they had a doctor using this in a clinical trial type thing, or just to see how they would use it, he pulled this box, which is where all the magic was happening, that was ending up at the end of this stylus that he was using, pulled it right off the bench because it was too short. And smashed it to pieces, kind of thing. Well, back to the drawing board. And I said, well, why was the tether or the cable so short? And it was a mixture of coolants and it had all kinds of stuff in it. But the energy that was being transmitted down it had a physical limitation of how far it could go before it was not effective anymore for whatever the treatment was. And I'm like, oh, okay. Well, you might want to make a smaller box that does the final bit closer, and all the bigger ones, further away from the operating table. We got to do something different here, because that yanking the cable to get to exactly where you want to be is the primary concern of physicians, to apply the treatment appropriately, not whether your box can hang onto the table or not, or put wheels on it so it just comes closer, or something.
That's not human error.
Yeah. But it was, they talked about it in various medical devices, is that trial with the real people. It's great when you have your own engineers and technicians do it, because they know they have that whole picture in place, not just the patient interaction. And I remember one time it was a product that had, it would dispense prescription drugs, and it was all locked down. And so the nurse would have to come up and type in a code, and then what the prescription was, and it would be computer linked. It was super fancy lockbox, basically. And the first thing they ran into is that instead of using the pad of their fingers to type in on the keypads, they used the pen or the end of a sharp object of some sort, and because they didn't want to have to decontaminate their hands again. So they'd grab a pencil or a pen or whatever and shove that into it. And it just ripped through the membranes on top of the keypads, such that it would not be, you couldn't clean it anymore. So it couldn't be in a sterile room. So as soon as you put decontaminant or cleaning solutions on it, it would corrode the keyboards and it'll fall apart.
Really?
And I was like, okay, you didn't know this? But it was a trade-off. Can we make these interactions and controls safe to be sterilized, but also usable? And so they had to go to a completely different, much more expensive technology that could beat both of those problems, because people that I got to push the button and there's all these other barriers for a variety of reasons why I can't. Well, I'm going to get out, the end of the scalpel and poke through there so I can push that button because I need to get my job done.
Yeah. And it's also another thing that springs to mind is that acceptance testing, the reliability demonstration testing that our militaries were used to be part of really enjoy, where they say, oh, the MTBF needs to be X thousand kilometers or miles, and we'll test until we demonstrate that we've met that requirement. And then no matter what happens, those vehicles or weapon platforms or whatever it is, those radios, when they get used in the field by real soldiers, all of a sudden they get things change. The apparent reliability decreases because they're being used in a very different way, and people are genuinely surprised about this. But then you ask yourself, well, why do we spend so much time? In some cases, it takes years to do this acceptance testing. How do we spend so much time and money in this acceptance testing where everyone knows that no matter how accurate you think you can replicate operational settings, your soldiers are going to find ways to use that thing in a way that suits them because that's their job.
Well, it's the same applies for customers of any product. If you don't really understand how they're going to use it, you're going to miss the mark, and they're going to use it the way they think that should be used. And whether it meets that requirement or not, they'll find out. And so it goes, just because we've always done acceptance tests by, highly skilled technicians that only use the equipment in a particular way, that's falling. There's no doubt about it.
Yeah.
But it goes back to that, when you design and there's people involved, you really do need to pay attention to, one, how they behave with your product and what they expect your product to do, but how will it evolve? Because it always does. The way we treat cell phones initially was completely different than the way we treat them today. And so,
if you don't want to adjust, then that's okay. So as W. Edwards Deming once said, you don't need to adjust. You don't need to change. Change is not necessary, but neither is survival.
That's right.
Pick one.
You got to be adaptable. Well, anyway, there's a bunch of different stories in there. I think we got the point across, is that you can't design out the human element of this thing, but you can design to accommodate it as best you can. And even then, you still got to pay attention. I don't know. I'm thinking if folks are listening to this, you probably have a handful of other stories that go along with this, or maybe spark some memories for you. Let us know. Or if you got a question, or we didn't touch really on the design practices of how to accommodate this thing, or how to adjust for it. I think we set the stage that you have to, but we didn't talk about too much of designing for people. But it might be a good question or two that could come in and give us a spark for a direction to go for those episodes. That might be a good thing to do. And you can do that over at accendoreliability.com/go/SOR. And you can find a way to leave us a voice message or a written message. And you can find Chris and I and the other hosts of the show on LinkedIn or on our About pages. So plenty of ways for you to get in touch. So I think I'm looking at my desk with pens and pencils and styluses and recording equipment and computers and drives and everything else. And I just hope my coffee cup is well taken care of so I can fill it up again.
That's right. Well, the only reason coffee is going to spill on the ground is not because your coffee mug fails. It will be because of human error.
Yeah, pretty much.
It'll work.
It's been designed pretty well, except for my part of it.
Right.
All right. Well, thanks for the idea for this one, Chris. And we'll talk to you again soon.
Always a pleasure, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.